What's going on, you bunch of filthy animals? I'm back. Day after my birthday. Tried to do a big 100-kilometer run. Failed epically. Got to about 50k, I think. And then I saw this beautiful McDonald's that was calling my name, and that was it. That was that. Before we get into today's video, I just want to spend 20 seconds trying to get you guys to sign up for my Cal VPN, the first VPN that'll protect you from quantum computers. It's coming. I'm building it. Hackers could be stealing your data right now to break in a few years when quantum computers exist. Google is trying to make one by 2029 to have a useful quantum computer, and so is a bunch of other companies. The tech, there's a lot of breakthroughs right now. That's really exciting. I'm going to make a dedicated video soon talking about all that when my software is a little bit further along. And thank you to everyone who's already done this already. But if you haven't, please go to calvpn.com. It's in the bio, and you can read about it if you want, and then sign up. Enter your email and click sign up. It'll help me get investors. So if you enjoy my YouTube or whatever, help me out. It'd mean the world to me. It was my birthday yesterday, so for my birthday. And again, thank you to everyone who has signed up. You guys are legends. Can't wait to tell you more. And it's just going to be an exciting journey. So get involved. Today, we're watching Morkurs Gesagt. The guy's a legend, and his videos are just so entertaining. What happens if the moon crashes into the Earth? Well, this is going to be fascinating.
Are answering an age-old, very scientific and important question. What if the moon crashes into Earth? It's more interesting and weird than you probably think. Let's start with the basics. Why isn't the moon on its way to crash into us already?
Good question.
We know that Earth's gravity pulls everything towards it, including the moon, but somehow it stays up, as if suspended by some opposite force. But there is no other force countering gravity. Instead, the trick to staying up is a sideways motion that we call an orbit. You see orbits every day. When you throw a ball, it makes a tiny little orbit. The only difference between the ball's orbit and the moon's is that the ball eventually hits the ground. Basically, the reason is speed. If you could throw your ball fast enough, it would bend around the world and come back to you. If there were no air slowing it down, it could orbit forever. And this is what the moon does, falling sideways around Earth very fast with no air slowing it down, orbiting Earth every 27 days at 3,600 kilometers an hour.
To be a bit more technical, it's actually the angular momentum and energy of the Earth-Moon system which keeps it in orbit. The system is basically trying to minimize its energy, which would be achieved through a collision. So, you know, angular momentum has to be conserved. So it's in this constant battle of trying to collide, which keeps it in orbit.
So for the moon to just stop in its orbit and plummet to the Earth would break more laws of physics than we have time to explain. So how do we crash it into Earth? In a nutshell, to change an object's orbit, you need to change its speed, which changes where gravity takes it. But even small changes require enormous forces, which is why all the large objects in the solar system are so stable nowadays. According to science, the moon is big and very massive. Even igniting billions of rocket engines all over its surface would barely move the moon. It looks like nothing short of magic will make the moon fall, so we'll use a magic spell that slows down the moon so much that it changes its orbit and spirals towards Earth.
So if you didn't know, in the future, in the far future, we've actually worked out that the moon and the Earth should collide. But before the moon crashes into the planet, it will break apart. We'll see if he talks about that later in the video. But I think it's currently estimated to be about 65 billion years in the future. So there's a small problem, and that's the sun's... it's going to run out of fuel before then and become a red giant. And we actually don't know if the red giant will actually eat the planet, eat Earth, and encapsulate it. We think it might. So, because what happens is red giants expand as... Let's not go into the stellar physics of it, but the red giant's going to get really massive, and then there'll be a white dwarf. But that's going to mess with the Earth-Moon system, obviously. Wreak all sorts of havoc. We just might be charred completely. But anyway, in the far future, if that doesn't happen, and, it remains relatively stable, well, yeah, the moon will start to creep inwards eventually. At the moment, it's actually moving away from the planet. So this movement of the moon away from Earth is actually caused by the effect of tidal friction of the moon's gravitational tides on the Earth. And it's interesting, the rate at which the moon is moving away from us is actually a function of the Earth's rotation and the dissipation of tidal energy of the Earth's oceans. We can actually get a pretty precise figure for this recession because of some gear we left on the moon, which it reflects light. So we shoot lasers at this, thing, and it reflects back at us. It's amazing. And we get a direct estimate. It's pretty interesting to note the shape of this reflector thing, because it's like you can shoot it at any angle at it and it comes back to you. So what shape must it be? Think about that. It's really confusing. It's very interesting. It's actually a great way to destroy, the moon landing conspiracy, how some people think we didn't go to the moon. Well, we can shoot this laser and it reflects back. So there must be a mirror reflector on the moon. Someone must have put it there. So then the reason why it'll actually start to come back and there'll be this, problem is because the Earth's rotation will keep slowing until it matches the moon's orbital period. And at that point, it'll start creeping inwards. And then this scenario will play out. But, by that time, the sun will be a white dwarf. And so the Earth would have frozen solid. And it would have been that way for billions of years.
To get the most from the experience, the moon will take exactly 1 year before it hits Earth.
Fun.
Ready? 3, 2, 1. Magic. Month 1. For the first few days, nothing really changes. The moon gets a tiny bit brighter and scientists get confused, but the rest of us don't notice anything different. The only noticeable real effect of the moon on the Earth are the tides. Tides exist because while Earth pulls on the moon's gravity pulls...
And everyone's behavior. No, that was a terrible joke. I'm trying to joke, astrology, right? Everyone thinks people are going crazy when the moon's full. And, when the moon is... This is actually an interesting thing to talk about. So, did you know... have you ever noticed when the moon is on the horizon, it looks way bigger, right? It looks huge. And then when it's directly above you or just up there, it looks way smaller. But when the moon is directly above you, it's actually quite a lot closer. It's about 50,000 kilometers on average closer. And on the horizon, it's about 50,000 kilometers further on average. That's quite a distance, right? So why does it look so much bigger on the horizon? There's an optical illusion at play here. Our brains are tricking us. And when the moon is on the horizon, there's things really close to it that we can compare it to. And so this might not be convincing you, but if I show you this picture, tell me which, I don't know what it's going to look like yet, because I'm going to find one post-edit after I make this. And tell me what do you think looks bigger, and I'll let you know down in the comments the correct answer, because it might just blow your mind. And that's what's going on here. But anyway, let's get back to it. And yes, astrology is just complete BS. When Mercury's in Gatorade, I don't think you need to worry. Do people have Gatorade in the rest of the world? I don't know if that joke works elsewhere. Retrograde, Gatorade. It's like Powerade, but better. Tastes like medicine.
Back on the Earth. Since the strength of gravity gets weaker with distance, different parts of the Earth feel a slightly different pull, which causes the Earth, especially the oceans, to bulge when the moon is above them and contract a little on the sides when it's not. As Earth rotates every day underneath the moon's influence fluctuates, causing the water level of the oceans to rise and fall by about half a meter twice a day. But with the moon drawing ever closer, high tide gets higher every day. At first barely noticeable, within a month the moon has covered half the distance to the Earth and ocean tides have grown to 4 meters. Every day high tide comes and waves flood coastal cities. And there's no end in sight. With the moon drawing ever closer, tides rise ever higher, inundating another city and more inhabited land with salty water every day. Month 2. By the end of month 2, the moon has covered 2/3 of the distance to Earth and global infrastructure is crumbling as tides rise above 10 meters, displacing up to 1 billion people who happen to live near the coastlines. As ports become inoperable, shipping grinds to a halt. Not only will it slow down the delivery of Kurzgesagt products, but also less exciting things like food. Global communications fall into disarray. 95% of the internet is carried by ocean crossing cables, and while these largely don't mind the water, their terminals on land do.
Don't worry, Elon Musk will save us for the Starlink.
Living inland doesn't guarantee safety either. Tidal bores cause rivers to flow backwards, carrying salt water to contaminate surface and groundwater supplies.
Interesting.
Gas shortages follow as oil refineries near the coast are abandoned. Countries are left with the supplies they had on their shelves, and strict rationing will begin. In the cities, chaos reigns during the scavenging hours of low tide, while survivors take refuge in high-rises when the water returns. 3 months in, and the moon is close enough to disrupt communication and navigation satellites. While it's normally far too distant for its gravity to cause any major problems for our satellites, the closer it gets, the more warped their orbits become. As their fuel for orbital corrections runs out, satellites careen out of control. Months 4 and 5. On Earth, the tides are rapidly growing to about 30 meters and will be reaching 100 meters in height in a few short weeks. At low tide, the ocean recedes hundreds of kilometers, exposing the continental shelf like vast deserts, while at high tide, walls of water drown agriculture, houses, and skyscrapers. And now, almost 5 months in, the apocalypse has finished its warm-up act. Since the oceans are on average only 3 kilometers deep, the tides have reached their maximum. Up until now, the water in the oceans could flow, absorbing most of the moon's gravitational squeezing, but now the Earth itself is really feeling the squeeze of the ever-approaching moon. These aren't so much tides of water, but tides of rock. The squeezing of the planet, combined with the weight of quintillions of tons of water sloshing on and off the tectonic plates, creates enormous stresses below and begins to cause earthquakes of increasing magnitude and intensity. It's impossible to say how serious these earthquakes might be or where they occur, but like a child jumping on their bed until it breaks, no good can come of it. Strong tidal forces lead to volcanism on other planets and moons. On Earth, squeezing the planet disrupts the magma reservoirs inside the crust, triggering sizable climate-altering eruptions in Chile, New Zealand, Yellowstone, and elsewhere. Meanwhile, watching patiently above is the moon. Still no bigger in the sky than a small cloud.
We'd be pretty well off down here in Australia because we're like right in the middle of a plate. It's great. We rarely get earthquakes. Everyone else, you're pretty stuffed.
75,000 kilometers of Earth, it is bright enough to illuminate the night sky like twilight. Months 6 and 7. After half a year, the moon is entering the space once occupied by geosynchronous satellites, where it orbits Earth every 24 hours. It appears to float at one spot in the sky, unmoving, cycling through a full set of phases every day, but only visible to half the planet. With the moon stationary above the Earth, the tides seem to freeze in place. Half the world flooded, half with its water seemingly returned to the sea, as if Earth is holding its breath to prepare for the worst. As the moon sinks further, you might wonder if its gravity would overpower Earth's, pulling you up and ending your misery. Fortunately not. The Earth's surface gravity is about 6 times stronger than the moon's, so even if the moon were hovering right on top of you, you would still stay on the ground. On the moon, things are different though. The near side of the moon is more strongly affected by Earth's gravity, so during the next few months, it starts to stretch forward towards the Earth into something of an egg, triggering deep moonquakes as the lunar rock flexes and changes shape. Though barely noticeable now...
Yeah, the moon does have earthquakes every so often. Moonquakes. So these are actually interesting. I remember reading about how we think the moon is about 50 meters skinnier and has gotten so over the last several 100 million years. And this is because the center of the moon is cooling, we think. And this is basically, and this shrinking is going to be causing moonquakes, which is pretty crazy. And things like asteroids and things hitting it also cause moonquakes. Anyway, let's get back to the video. The big exciting part's about to happen.
In a matter of months. Months 8 to 11. At this point, the apocalypse has arrived, and we can summarize the months before the crash as everybody left has a really bad time. The tides sweeping
Except
over
for
the
Noah
Earth
on his
slow
arm.
down and then reverse their direction because the moon now orbits Earth faster than it rotates. The planet will experience
Wow.
an abundance of earthquakes and volcanism. Massive amounts of volcanic aerosols rise high into the stratosphere, shiny enough to reflect sunlight back into space. What little light gets through is rust red and is periodically diminished by daily eclipses. The result is a rapid global cooling with acid rains and summer snows killing even the hardiest plants. The clock runs out on civilization. Billions have perished while an X-shaped
I don't know if that would happen. I think it might actually be the opposite to what he said. Really dense clouds would, yeah, it would reflect a lot of the sunlight. But for the photons that get through, they would actually be kind of stuck in that system. And so it just gets warmer and warmer. Kind of like what's happening on Venus, where it's 500 degrees Celsius on the surface, because it's got this thick gaseous layer around, all these greenhouse gases. And, so because what happens, a photon some would get through, and then they would bounce off the surface back up, and then they'd hit the clouds, and then it'd straight back down. So global warming. Whereas what happens on Earth is, the ones that get through to the ground, they bounce back up, and they don't stop. They just keep going. So that's a big part of global warming. With what's currently happening to Earth, that's one of the worries. Like enough greenhouse gases in the sky, photons will, bounce off the surface and then bounce off it again, and then it stuck in the system. Anyway.
Moon is still drawing closer. Let's get ready for the grand finale. Month 12.
Final month.
Finally,
Fight.
at the end of the year, the moon has reached the Roche limit. That's the point where Earth's gravitational pull on the moon is stronger than the moon's own gravity. Things on the lunar surface start falling towards Earth, and by the time it crosses 10,000 kilometers, the entire moon disintegrates into rubble, smearing itself into a massive ring system around the Earth. Fortunately, the moon's disintegration means the misery on Earth.
I honestly didn't think they were going to talk. I thought they were going to, show some kind of slam, and I was going to be like, that probably wouldn't happen.
No moon means the general apocalyptic nature of things comes to a halt. The oceans recede, flowing off the land one last time. Any survivors are treated to a view of tremendous arches spanning the sky, glimmering in the sunlight, illuminating the night sky more brilliantly than any full moon ever could, while meteor showers of moon dust fill the sky. It's hard to say what happens next, but the tranquility may be short-lived. If too much moon dust rains down, friction heats the atmosphere, possibly boiling the oceans. If not, the enormous shadows cast by the rings, combined with all the volcanic and meteoric aerosols, block even more sunlight, and a period of runaway cooling could begin that freezes much of Earth's surface solid. In any case, at some point people will emerge again, from submarines or bunkers or mountain tops. They will not have a great time before rebuilding civilization.
Yeah, I think we'd survive it because, there would be no sort of nuclear radiation around, which would happen in a nuclear aftermath, when we talk about nuclear winters and stuff. Whereas this, it'd be bad for a long time, but people, I think, would survive this, like you said.
Their success is not guaranteed, but at least they'll be trying to do so with beautiful rings in the sky.
Always look on the bright side of life, my friends.
So how do you calculate that sort of thing? Well, you just need a bit of insanity.
Before we finish up, let's go read some of these comments. Great video, and a question with a spoiler. Is this actually how rings around planets are formed? Like around Saturn and Uranus? I did not expect to learn that. Yep, sure is, but not all the time. Yeah, there's billions of little... They're not actually that little. There's some of the things around in that ring system are like bus size. Just compared to Saturn, they look little. Because Saturn is massive, way bigger than Earth. But yeah, you're exactly right. If the moon gets too close, it just goes, and then it becomes a ring system. One thing I wonder about is even in this scenario where it safely deorbits into a ring, would the Earth still end up being pelted with massive meteorites? Sure would, my friend, because as it breaks apart when it gets too close, some of those would be launched towards the planet. But, you know, it wouldn't be that bad. I mean, it would be bad if you're in the way, but it would be fine eventually. So it would actually be really great for a movie. I thought were about to say in real life.
If you want to be like Sheldon and learn some physics, but you don't know where to start, or you think it's too hard, Brilliant is a great option because it makes it fun and easy. Brilliant have sponsored this video, so a big thank you to them. Trying to learn physics by just watching, it's a bit like trying to learn how to ride a bike by watching someone else ride a bike. Learn interactively with Brilliant's fun, hands-on lessons in math, science, and computer science. There's been some work to show that learning interactively actually helps you learn 6 times more effectively than just watching lecture videos. Join millions of people already learning on Brilliant with a special offer just for you guys. Head to brilliant.org/DylanJDance to get started for free learning with Brilliant's interactive lessons. The first 200 listeners will also get 20% off an annual membership. So thanks again to Brilliant. Check them out if you want to learn some physics. Let's get back to the video.
All right, that'll do for today's video. Thanks for watching, guys. Make sure you subscribe. Go check out CalVPN. Put your email in. Don't forget. I'll catch you next time.